Good day. We are Team Hard Rock, and today we'll be talking about the geological investigation of our city, which is Mandaluyong City. So here are our group members. First, we have Brendan Agero. Next, Bryce Du, Vincent Lim, Nathan Tan, and me, Aldrich Tilos. So, in today's agenda, we'll be talking about introduction of the city, geologic structure, lithology, groundwater conditions, and the seismicity of Mandaluyong City. So let's start with the introduction. Mandaluyong City is located in the second district of the National Capital Region. It's usually called as the Tiger City of the Philippines, shopping mall capital of the Philippines, and Metro Manila's heart. It has 27 barangays and it has 1,124.97 hectares, which is 1.77% of Metro Manila. So it's called the shopping mall capital of the Philippines because it has the well-known shopping malls, uh, which are SM Mega Mall and Shangri-La. And here is a map of Mandaluyong City. There, it's big. Okay, next.
Moving on, the geologic structure of Mandaluyong is that the terrain of the city is partially flat in the southwest area, while the rest is mostly rolling with gentle slopes. In the northeast area, there are higher slopes that allow for an ideal setting or landscape for a world-class golf course. The lowest point of the city is inland, and this is almost always affected by flash floods during the rainy season. Mandaluyong has a river coast that spreads at an elevation of around 3 meters, and this is supported by concrete embankments. Its surface area is mostly covered with loose to granular clay loam as well as granular clay. However, underneath that is a solid foundation of compact adobe. Next. This is a picture of the world-class golf course in the northeast area.
Okay, so for Mandaluyong's lithology. So the lithology of Mandaluyong is mainly composed of quaternary alluvium. This is a deposit that is made up of soft clay, silt, and loose sand. It can be classified into two categories, which are continental sediment and marine sediment. The composition of the deposits is usually not distributed evenly, hence an uneven balance of clay, sand, and silt. This composition is caused by marine regression at the Manila Bay and Central Plateau that occurred 7 millennia ago. So, alluvium is loose in nature, and because of this, it is often eroded or carried away by flooding or river waters. This results in its transportation somewhere else, and eventually it will pile up and lithify into a solid rock. Uh, for its morphology, this can vary depending on how the deposits were formed and the age of the deposits, but they are generally similar in its morphology. So, using this liquefaction hazard map, we can see that Mandaluyong is highly susceptible to liquefaction, and this is because of its lithology. It is mainly composed of the loose alluvium.
So moving on to the groundwater conditions. The city of Mandaluyong has two sources of water supply. One would be the Angat Dam, which discharges a capacity of 18,000 liters per second, and the other would be groundwater or deep wells that have a discharge capacity of 460 liters per second. So currently, the city of Mandaluyong has two PDF or Presidential Task Force deep wells, which adds to the water supply to barangays such as Plainview and Barangka Drive. Additionally, the city has around 60 public wells that supply households that lack connections from water distribution systems, and 18 other deep wells supply the industrial sector of the city. Evidently, even though the majority of the water supply comes from Angat Dam, a major part of the city still relies a lot on groundwater, as about 32% of its population depend on dug wells for their water supply. So here's a picture of how a deep well looks like and what it's composed of. So there's a pump head, well casing, a drop pipe, a pump rod, and the cylinder. So next, please. Here is an image of a deep well being used here in the Philippines.
Now on to seismicity. Mandaluyong is still prone to earthquakes and is affected by earthquakes made by the movement of tectonic plates because it rests on the Pacific Ring of Fire. Aside from that, Mandaluyong is mere kilometers away from the West Valley Fault. It is a strike-slip fault that runs through NCR to Calamba, and it poses a threat to the region as a whole, the whole NCR. So throughout the years, Mandaluyong was only struck by weak to moderate earthquakes, measuring up to 5 to 6, magnitude 5 to 6 on a Richter scale. So now we have a picture of the Pacific Ring of Fire. The Pacific Ring of Fire, as everyone knows, is a path along the Pacific Ocean characterized by active volcanoes and frequent earthquakes. The majority of Earth's volcanoes and earthquakes take place along the Ring of Fire. So here is the Philippines, as you can see. So it is sandwiched by the Pacific Plate and the Eurasian Plate. So that's why it has many earthquakes. Aside from that, we can see this is a picture of the West Valley Fault, and Mandaluyong is on the path of the fault. That's why it is very prone to the earthquake or the big one. That's all for our presentation. Thank you.